Welcome to another segment of High School Geometry with Netz and Weichel. This is Mrs. Netz,
And this is Mrs. Weichel.
and today we are looking at 5.3 coordinate geometry. What will we be learning? Well, by the end of this lesson, you will be able to understand various polygons, their properties, and apply those properties to solve geometric problems. Why is this important? Well, understanding the relationship between shapes and sizes, you will better be prepared to use them in everyday life. How will you know you understand it? Well, you will know you've mastered this when you can verify the classifications of geometric figures using coordinate geometry to find lengths and slopes. To kind of put this all in a really quick, nice little box, we're going to look at the properties of your quadrilaterals, parallelograms, pretty much a lot of our shapes are triangles. We're going to look at them on a coordinate plane and see if we can apply the properties that we have learned about them in previous lessons to the information that we get off of the coordinate plane.
All right, so let's go ahead and get started. Couple things. One, the distance formula is used to find the length of segments. So, like for example, when we're looking at properties of triangles and quadrilaterals, if there need to be congruent sides, we can use distance formula to prove or disprove whether or not we have congruent sides.
So for example, if you were looking to prove that you had a square, you would have to use distance formula if your square was not sitting nice and straight, and you'd use distance formula to find all four sides are congruent.
So you can go ahead and fill in the words distance formula, and then you can again write down what the distance formula is if you need to.
Or I can sing the song again. No.
All right, next. You know a parallelogram, the diagonals bisect each other, so we would need to calculate our midpoints. So if you decide to prove a parallelogram using this property, you would need to use the midpoint formula for your diagonals to see if they share the same midpoint. So again, this is going to be used to find the middle of a segment. So our midpoint formula is on the screen for you. Please go ahead and copy that down here. Again, you would use this to find the middle of a segment. And then we're also introducing the centroid formula. This is used to find the centroid of a triangle, not of a segment. That should say triangle.
Whoops. But wait a minute, are we really introducing this?
We are, because they have already done it in the last lesson. We talked about centroids, so we're going to introduce.
So we're not really introducing it. They already know it.
You guys should already know what a centroid is. This is just another way we can calculate what it is. If you remember in lesson 4.5, we constructed the centroid using our compass and straight edge where the medians intersected. That was our centroid. Well, what if the coordinates or the vertices of a triangle are on an x and y coordinate plane? Well, then you would be able to use the coordinates and this formula, which should look familiar. It looks very similar to the midpoint formula. You just are adding a third vertex, and now you're dividing by 3 rather than 2. And the coordinates you get for, I went ahead and did sub C for centroid. That would be, again, your ordered pair answer. So you can treat this like an ordered pair. All right, to recap, your 3 different triangles when we're looking at side lengths. The first we don't talk about as much, I feel like, is your scalene triangle. That is when you have 3 different side lengths. None of them are the same.
You know how I remember that it's a scalene triangle?
How?
Well, every time I step on the scale, it says a different number.
That could be a good thing, too.
Not when it's going up.
All right, and then an isosceles triangle, if you remember from chapter 3, is when you have at least 2 congruent sides.
You want to know how I remember this one?
How?
If I take 2 fingers and point them at my eyes, my fingers kind of make an isosceles triangle.
And then lastly, an equilateral triangle has just 1 side length. All 3 of them are the same.
You want to know how I remember this one?
Please tell me.
All the sides are
equal. So I went ahead and used congruency marks. Here you can see we have 3 different ones. Here we just have 2 different ones. And here we just have the 1. So if we were going to prove that we had one of these types of triangles, you would use distance formula to calculate the length of the sides. If any of them are the same, it changes from scalene to isosceles and then equilateral. So let's that's what we're going to go ahead and do here with our first one. Go ahead and graph triangle ABC given the coordinates at negative 9, 5, negative 3, 3, and negative 9, negative 5. You should get triangle ABC as you see on your screen. We're going to go ahead and do the distance formula for all three sides, and then compare the three sides to see if we have a scalene, isosceles, or equilateral triangle. When we're done doing this, we're going to go ahead and substitute in the three coordinates into our centroid formula and calculate our centroid.
Good luck!
Okay, so hopefully you guys went ahead and tried this because we did distance formula pretty significantly in lesson 5.2. For the first one, AB, you should have gotten all of this. Sorry, it's a little small, but you should be able to see it on your computer screens.
Well, that's a lot of math in that little spot.
I wanted it to fit. So we went ahead and used the distance formula right here. You can see that I plugged in points of A and B in for our X and Y spots in our distance formula. Negative 3 plus 9 gives me 6, and 3 minus 5 is negative 2. When I square both of those, I get 36 and 4, and then you get the square root of 40. Square root of 40 can be simplified. I didn't simplify it here because you're just using this number to compare it to the other two sides. So we want to see if we get square root of 40 for any of the other two sides. The next side we're going to go ahead and do is side BC. So again, I went ahead and wrote the distance formula and substitute in point B and C in my X and Y spots. Negative 9 plus 3 is negative 6, and negative 5 minus 3 is negative 8. When I square both of those, I get 36 and 64, which gives me the square root of 100, which is 10. So far we definitely do not have an equilateral triangle due to the fact that we have two different side lengths here. So now what's underneath the green one for side AC is going to decide, do I have scalene or an isosceles triangle? So you can go ahead and see here that when I plug in my A and C coordinates, I end up getting negative 9 plus 9, which is 0, and negative 5 minus 5, which is negative 10. 0 squared is 0, and negative 10 squared is 100. You end up getting the square root of 100, which is 10. So because I have these two side lengths, we are able to say that this is an isosceles triangle. And I can actually go ahead and add in my congruency marks. I know that AC is congruent to BC. All right, next with the same triangle, we're going to go ahead and calculate our centroid formula. This one's going to be easy. All you need to do is plug in your x's and your y's into this formula. So you're going to find the sum of the x's divided by 3, sum of the y's divided by 3. Our three x coordinates are going to be negative 9, negative 3, and negative 9. Our three y coordinates are going to be 5, 3, and negative 5. Over here on x, negative 9 and negative 9 is negative 18. Add that to negative 3, we get negative 21. Over here, the 5's cancel out and you're left with 3 over 3. Lastly, we can divide these out and get integers. Negative 21 over 3 is going to be negative 7, and 3 divided by 3 is going to be 1. So we can go ahead and write that the centroid of this triangle is at negative 7, 1. All right, we're going to go ahead and do the same thing for the second problem. I'm giving you points of A, B, and C at negative 5, 5, 0, 4, and negative 4, 3. We're going to classify this triangle by the side lengths, and then you're also going to calculate the centroid. So I would love it if you would pause the video and go ahead and see if you can do this one by yourself.
I think I can totally do this one all on my own.
Good luck. Okay, so the first side length I went ahead and found is AB. If you plug it all in, you should end up getting the square root of 26, which is not a perfect square, so I went ahead and left it as such. For the next side, we have BC. I got the square root of 65 for my side length, which is not the same, so once again, we do not have an equilateral triangle. For our last side, AC, I also got the square root of 65 when I worked this out. So because we have side BC being the same length as side AC, we can say that this is an isosceles triangle. There we are. And then lastly, we are going to calculate the centroid by plugging our information into the centroid formula. So the first thing we're going to do is take the negative 5, 0, and negative 4, the 5, the 4, and the negative 3, and plug that in. Negative 5 and negative 4 make negative 9. 5 plus 4 minus 3 is going to give me 6. Both of those are divisible by 3, so you should get an x-coordinate of negative 3 and a y-coordinate of 2, giving me a centroid location of negative 3, 2.
Very cool.
All right, the next problem, Mrs. Weichel goofed and drew the wrong triangles, so rather than having you guys try and fix it, we're going to go ahead and just skip this problem.
We get to skip a problem?
We do.
We get to skip a math problem.
Yay.
We have permission to not do a math problem?
You have permission to skip this problem.
Oh, yes.
Because of my goof up, that's my present to all of you.
Bless. Skip.
All right, so we're going to move on to the next page. Recap, parallelograms. We know that parallelograms must have two sets of parallel sides, opposite sides parallel right here and right here. You can go ahead and take the time if you would like to write down all the properties. You know opposite sides are congruent. You know opposite angles are congruent. You know the diagonals bisect each other. Any of these can be used to prove that you have a parallelogram. I'm going to go ahead and dissuade, is that a word?
Sure.
Not persuade you. Don't do the opposite angles. That's a difficult one to try and prove on a coordinate plane. It's very easy to prove if you have opposite sides parallel through slope. It's very easy to prove opposite sides congruent through distance formula, and it's very easy to use bisecting diagonals through midpoint formula. Those are going to be the easiest ways to prove that you have a parallelogram.
Yeah, let's not go measuring any angles right now.
To be a rectangle, you have to have right angles. So the best way to do that would be for me to look at slope. If you have those flipping opposite slopes, you know you have right angles. And if you have 4 right angles, you know you have a rectangle.
Wait, how do you know it's not like a square, 4 right angles? Hello?
Because if all you know is you have 4 right angles, you cannot say it's a square. Now, if you have a rectangle, I would check to see if you have a square. But in order for a rectangle to be more specifically a square, you would need to know you have 4 congruent sides as well.
Oh, so wait a minute. All squares are rectangles?
That is perfect, Mrs. Nets. Good job.
So weird. Like, I could look at a square and tell somebody that's a rectangle and they'd have to agree with me?
Yes.
I would love to challenge our students to go home and do that to their parents.
There you go.
That would be so fun.
Have a good conversation with your parents.
Like, that's a rectangle.
Put them to school. All right. To be a rhombus, you would need to show that you have 4 congruent sides. So again, that would fall under the distance formula category. And then lastly, to be a square, as I just previously discussed, if you look, you'd have to have those opposite reciprocal slopes to show you have 4 right angles. And you'd have to use distance formula to show that you have 4 congruent sides. All of these are methods that you can use to prove that you have these. Another one for a square, you could use the diagonals. If you can show that the diagonals are perpendicular and congruent, you know that you have a square.
Just be very careful, because I see a lot of students, they'll show that the 4 sides are congruent, and just having 4 sides congruent is not enough to say you have a square, because all 4 sides of a rhombus are also congruent. So therefore, if I just say all 4 sides are congruent, you don't know if it's a square or a rhombus. Sort of like, I don't know, Mrs. Weichel, maybe we should play kind of a little bit of a game, like, what shape are we thinking? So if I say to you, what shape am I thinking has 4 right angles, do you really know for sure?
I don't, because that actually fits into multiple categories. If that's the only information you give me, the only answer I would be able to give is rectangle.
Oh, what if I tell you opposite sides are parallel?
Again, I wouldn't know what you're thinking because multiple shapes fit under that category, but only telling me that, the only answer I can safely give is parallelogram.
Okay, so then what if I say opposite angles are congruent?
Same as the previous one. That's going to be a bunch of shapes, but for sure it has to be a parallelogram.
So you can't say for opposite angles that it's a rectangle. You can't say for sure it's a rhombus. You can't say for sure it's a square.
You cannot. You have to know more information to go to a more specific shape.
There's the key. You've got to know more information to be able to tell us what shape it is we're talking about. So almost think of this as like a mystery solving type of game. If I give you a specific characteristic, can you tell me for sure, absolutely, positively what it is? Because if you can't, then you kind of have to lean toward the less specific. So if I tell you I'm thinking of something that has four wheels,
can you say for sure what it is?
I wonder what it is. What do you think it is, Michael?
A wagon?
No, not a wagon. It was a truck. See, you got it wrong. You needed more information.
You need more information.
Okay.
The more specific you go, the more information you need.
So this is another case in point where we can tell you your vocabulary is going to be critical, and not just not just knowing the vocabulary words, but truly understanding them.
Correct. All right, so let's go ahead and do this. The problems are going to be very similar to the ones we just did with the triangle. With this one, you're going to go ahead and graph MAIL at coordinates -3, 2, 2, 8, 5, 2, and 2, -4. So graphing it, you can kind of eliminate some things. I think you can kind of eyeball it. I'm thinking this doesn't look like any of the shapes, so this might be another Mrs. Weichel goof up, but that's okay. We can still go ahead and prove or disprove what we think it is.
Let's go for it.
So for what we've done in class, the most general shape we talked about was quadrilateral.
Well, that totally.
We can tell this is definitely a quadrilateral. The next most general.
Wait, why can you say absolutely it's a quadrilateral? Hold on, pause. Why?
Because by definition, a quadrilateral has four sides. This clearly has four sides.
That's all I need?
That's all you need to say it's a quadrilateral.
Oh, well, good. Hey, check.
Good.
What's next?
So now if we go more specific to a parallelogram, to be a parallelogram, you have to show that you have parallel sides. Well, if you go ahead and work out and calculate your slope, you're going to see some things. So I'm just going to use my rise over run over here. My increments are in twos. So from M, if I go up 2, 4, 6, and then to the right 2, 4, and then 5, I'm getting a slope of 6 over 5. If I go ahead and do that for the next side, AI, I'm getting down 2, 4, 6, right 2, 3. So I actually have a slope of -2, down 2, right 1, down 2, right 1, down 2, right 1. For IL, I'm going to go up 2, 4, 6, and then 2, 3. And then for ML, I'm going to go down 2, 4, 6, and right 2, 4, and then 5. So these are the slopes that we're getting. If you remember from our first lesson, to be parallel, you have to have same slopes, which none of these are. So because none of these slopes are the same, we cannot say that MAIL is a parallelogram.
Sad face. So does that mean we're like done? Like we can't go any more specific? We can't say it's a square. We can't say it's a rectangle.
I did go ahead and do this, and the only reason I did this, even though we don't talk about it, I think you might see it on Khan Academy. So I thought this was a good time to maybe mention this. If you calculate side lengths, which you guys have plenty of room to actually do distance formula and work it out, these are the 4 side lengths you should get. What do you notice about them?
Well, when I'm looking at my side lengths, I see hold on. 2 of them have a side length that's square root of 52, and 2 of them have a side length that's square root of 61. Wait a minute, this has got to be a rectangle. Totally.
So, none of our slopes are perpendicular, though, so no right angles.
But we have 2 sides that are the same. And then another 2 sides. Oh, no.
So, they're not opposite, though. If you look at this, the consecutive sides are actually congruent to each other. And again, this is not something we went over in class, but you, I believe, see it on Khan Academy. We would actually say that MAIL is a kite. So I will tell you that we won't give you one of these on a test in our class because it is not something we really cover. We would lean towards the parallelogram, rectangle, rhombus, square world. But a kite is going to be a quadrilateral with 2 sets of consecutive congruent sides.
So it's a little bit different than your rectangle in that a rectangle, the opposite sides will be congruent. In this case, it's going to be that one side, we said consecutive. So consecutive means one right after the other. So if you're standing in line for lunch, the person in front of you is consecutive. So one right after the other are the same. So therefore, this will be a kite.
All right. So if you would like to go ahead and pause this and see if you could prove or disprove what you think BAKE is, go ahead and do so, or you can follow along with us. So looking at this, I like to kind of look at it and make a conjecture on what I think it is and then try to prove it algebraically what it is. I think this looks like a square. So I know to be a square, I need to know that I have perpendicular sides and they need to all be congruent to each other. So I'm going to go ahead and find the slopes. And I'm going to find the slopes to use the fact that I have right angles.
Well, hold on. Wait a minute, Mrs. Weichel. I've got to graph this thing real quick.
Okay, so go ahead.
Sorry.
Okay, so you should have graphed your square. And again, I'm going to calculate my slopes by just using my rise over run. So I can see that BA, from B to A, I'm going to rise 2, and I'm going to run 1, 2, 3, 4, 5, 6. So up 2, right 6 would be the same as up 1, right 3. And I'm going to go around my quadrilateral here, and I'm going to see what the relationship is of my slopes. When I do this, I notice that I have opposite sides are parallel because their slopes are the same. I also know that the sides that are not the same with my slopes, they are opposite or negative reciprocals. What is the opposite of positive? Negative. And what is the reciprocal of 1 over 3?
3 over 1.
So these are perpendicular to each other. So I actually, at this point, know that I have at least a rectangle because I know these are 4 right angles. Because by definition of perpendicular, we're making right angles.
So remember, again, this is a mystery solving game. You are trying to solve the crime as specifically as possible. Like, what room did it happen in? With what weapon? Like, what's the crime? So, as of right now, best you know, possibility is a rectangle.
Now again, just by eyeballing this, I think it could be a square, not just a rectangle. So now I need to go ahead and go one step further and find my side length. So we're going to use distance formula to find the length of BA, AK, KE, and BE. We're going to see if they are all the same. If they are not the same, then all I can say is that this is a rectangle. So go ahead and pause the video and do that. Okay, what you should have come up with is that all 4 sides have a length of square root of 40. So because I have 4 right angles and I have 4 congruent sides, I am able to say that BAKE is a square. I proved enough information to, without a doubt, say that that is the shape that I have.
So it's almost like we figured out like the crime all the way to the end. We know who did it. We know the room. We know the weapon. We know everything.
Do you like the game Clue, Mrs. Nets?
Maybe.
All right, so hopefully you guys feel good about classifying quadrilaterals and triangles given coordinates on the coordinate plane. If not, please, again, as always, reach out to us and ask your questions.
Hey, Mrs. Weichel.
What, Mrs. Nett?
I see you have some graph paper.
You're right, I do, because I'm graphing.
You must be plotting something.
You are just on a murder kick.
I am.
Plotting
It's like a mystery solving, like, unbelievable. Guess what?
What?
I have another mystery.
What?
Guess what the next lesson is?
What?
5.4.
We'll see y'all then.
Bye.